Okay, number 5, here we go. Getting bored of these colors. All right, how many grams of chlorine gas can be produced if 12 moles of FeCl3 react with 12 moles of oxygen? Okay, so lucky you, look, it's already given in moles. So that means we don't need to do anything. I already have what I need. I don't need to do any converting because it's already in moles, so no need to convert. Okay, so be careful of that. Okay, all right, so let's look at my balanced equation. I see some 2's and 3's in here. Let's see what's going to happen. Okay, O2, O3. Okay, that's going to be one of those ones where we're going to have to make everybody have 6 total. Let's see if this works out. Okay, so now my oxygens are balanced. Over here, now I can see I have 4 irons, but only 1 over here. So let's give this a 4. Okay, so now I end up here with 12 chlorines over here, so then that's going to need to be a 6. Okay, so 4, 3, 2, 6. All right, so I'm starting with 12 moles of each of these, nothing in my products. All right, so this is super easy when you start with the same amount because it's going to be really easy to find the limiting reactant. Okay, so I need 4 iron, 3 chlorides, and 3 oxygens. Okay, so I need less oxygen than iron, and I have the same amount. All right, so since I need more iron 3 chloride, that one's going to run out first because I need more of it, and I'm starting with the same amount. Okay, so that's going to be 0, so that's going to be my limiting reactant. Okay, and then let's go ahead and fill out the table for everything else. All right, my given goes on the bottom, all right, because that was the one I started with, the iron 3 chloride. Bring down the coefficients. Okay, so 12 times 3 over 4 is 9. All right, so if I started with 12 moles of oxygen, I only use 9. So I'm going to have 3 left over. Okay, 12 times 2 over 4, which is a half, is going to be 6. And 12 times 6 over 4, which is going to be 18. Okay. All right, type of reaction. All right, we didn't really do this one as much, but this is also a single replacement, but it's just not replacing the metal. It's replacing the non-metal, right? So that one's a little bit trickier. We didn't really practice those, but it's still a single replacement because it's replacing one of the elements. All right, word equation, I have 12 moles of iron chloride. Okay, remember that's going to need a Roman numeral because it's iron. My chlorine is a -1 charge, right? But there are 3 of those, so it's a total of a -3. So I'm going to have +3. And I only have 1 iron to do that, so it's going to have to be iron 3 chloride. Okay, and 12 moles of oxygen react to form 6 moles of iron 3 oxide. Okay, it still needs that Roman numeral, and 18 moles of chlorine. Okay, remember it's just chlorine because it's not in a compound. All right, 3 moles of oxygen remain. All right, because I have that much left over. Okay, all right, let's see what it's asking for here. How many grams of chlorine gas? Okay, so I can see here that I have 18 moles of chlorine at the end, but it's not asking for moles, it's asking for grams. So I need to use my molar mass. Okay, and chlorine is like, what, 35 something times 2. So 70.91 grams of Cl2. That is going to be a lot. Times 18 is going to be 1276.4 grams of chlorine. And that's the final answer.